Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
Hello guys, I'm Dhiraj and I welcome you all at the Testbook.com, and I'm here to provide you the best I have. So guys, once again, I'm came back with another brand new session for previous year question based on refrigeration and air conditioning, right? So we have already finished what, bacha? We have already finished the thermodynamics, right? So I can see that few people have already joined. So guys, those who have joined, they have to do it, like, share and subscribe the session, as well as they have to share the link of this video इन योर सोशल मीडिया ग्रुप, सो दैट क्या होगा, उससे आपके दोस्त भाई बहन जो भी प्रैक्टिस करना चाहते हैं प्रीवियस ईयर की, दे विल गेट बेनिफिट ऑफ दिस सेशन, राइट? सो बच्चा पार्टी, वी आर गोइंग टू प्रोसीड. अब धीरे धीरे प्रोसीड करेंगे, बट बिफोर दैट लेट्स वेट फॉर 1 minute so that the people will get join and will get benefited as well, right? Okay, उनको फायदा भी होगा. So guys, will wait for 1 minute and then we'll begin the session. That means within 1 minute we'll start the session, bacha party. Okay, we'll start the session within 1 minute. Okay, so I can see that people are waiting. So right now it's 3 p.m. So guys, I want to let you know, those who have joined the first time, so guys, we have something special for you. That is nothing but Testbook Pass we are giving just for rupees 299. In addition to that, we are also giving Ghana Plus subscription for 3 months, and by the help of that you can listen to the motivational music, है ना? Motivational music भी सुन सकोगे आप. Okay, and one more thing that I want to tell you, that we have Gate Mechanical live coaching. You are getting it just for rupees 3,999, right, my dear? And in that you are getting personal coach, you are getting PDF notes, you are getting live classes, you will get what, my dear? You will get doubt session as well, right? So if you are already benefited of this session, my dear, then tell your friends as well. Okay, and if you are interested in SSC JE Mechanical live coaching, then my dear, the application form for this SSC JE Mechanical live coaching has been provided in the description of this video, as well as the link is also provided in the chat section, right? So guys, you have to fill the application form, and whatever the queries you have, definitely that will get sorted by the Testbook counselor. Okay, so guys, these are the various offers and kind of opportunities for you guys to crack any examination by the testbook.com. Okay, so guys, right now we are on the verge of starting our session. So guys, here I start and here I go for the first question. Chale bacha party. So here, this is the first question of today's. So see what they said, and we have already started RAC. Okay bacha, so see, a thin layer of water in a field is formed after a farmer has watered it. Okay, the ambient air conditions are 20 degrees centigrade, that is drive up temperature, and relative humidity, that is 5. It is what, bacha party? It is 5. An extract of steam table is given. Okay, neglecting the heat transfer between water and the ground. Water and ground में heat transfer क्या है? 0 almost. That we have to neglect. The water temperature in the field after phase equilibrium is reached. We have to find out temperature corresponding to what, my dear? Corresponding to PV. किसके corresponding? PV के. Okay, so my dear, see what they said. The temperature in the field after phase equilibrium is reached equals to, that means they are asking for the pressure equivalent to what, my dear? Equivalent to vapor pressure. Okay, so guys, now listen to me very carefully. You know that phi is equal to what, bacha? Phi is equal to PV upon PVS. Am I right? Yes or no? PV upon PVS, right? Yes or no? So from here you will get PV. यहाँ से आपको PV मिल जाएगा. Yes or no, bacha party? Of course you can get it, right? So my dear, see, from here phi is what? 0.05 PV, that we have to find out. PVS is given, and that is nothing but temperature is 20 degrees centigrade. So definitely we are going to see the table, and we are going to see 20 degrees centigrade, and corresponding pressure is what, my dear? 2.34 kilopascal. So my dear, from here you are getting PV, and PV will become what, my dear? कितना आ रहा है बच्चा पार्टी ये? Yes, बच्चा पार्टी. Guys, it is how much? It is 0.117 kilopascal, right? कितना आ रहा है बच्चा? 0.117 kilopascal. It is 0.117 kilopascal. So here I can write 0.117 kilopascal, right? Here you are getting 0.11 kilopascal, right? But if you see that, my dear, if you see the observe the table, you are getting 0.10, you are getting 0.26, right? Means in between this two values of pressures, we have the value of what, my dear? 0.117, and corresponding to that we have to find out temperature, right? But here they have not given directly. So what we'll do? We'll do the interpolation. So my dear, if I want to find out temperature at that particular pressure, my dear, what I'll do? See, what I'll do? I will took minus 15. That is, it should be more than from minus 15, right? Minus 15 plus in bracket. See, my dear. Just see here. Observe, observe, observe. देखो ध्यान से. It is what? It is minus 10 plus 15, right? क्या हो जाएगा? minus 10 plus 15 होगा, right? ना minus 10 plus 15, right? Very good, very good. So see here, my dear. So I can put minus 10 plus 15 divided by what, my dear? 0.26 minus 0.26 minus 0.1, right? Multiplied by क्या होगा बच्चा? Multiplied by, yes, anybody of you, multiplied by 0.117 minus 0.10, right? This is formula of what, बच्चा? This is formula for calculating temperature, and once you do the calculation, my dear, you will get कितना मिलेगा आपको? You will get minus 14.46 डिग्री सेंटीग्रेड. कितना आ जाएगा? minus 14.46 degrees centigrade, and this will be your answer. This will be your answer. Okay, this will be your answer. Minus 14.6, that is 46, that is minus 14.5. Number 3 will be correct option. Number 3 will be correct. I hope everybody got it. I hope everybody got it. Okay, that's great. That's great, bacha. Here I go. Here I go for another. See, these are the question has been asked in the GATE examination, right? So guys, now I'll go for the next one. Yes, if anybody have any issue with this question or any kind of solution, then my dear, you can just put your doubts in the comment section, or you can say in the chat section as well. Okay, so here I go for next. The statement concern psychrometry chart. Okay, constant relative humidity lines are uphill, straight line to the right. Okay, constant wet dot temperature lines are downhill, straight line to the right. Constant specific volume lines are downhill, straight lines to the right. Constant enthalpy lines are coincident with what? Constant wet dot temperature lines. Which of the following, which of the statement are correct? Guys, be fast. कौन सा correct होगा? बच्चा पार्टी, be fast, my dear. कौन सा correct है? Which one is correct? Which one is correct, my dear? Yes, WBT lines are not coincident, right? Now coincide नहीं करती हैं वो. Okay, so my dear, now you tell me. Now you tell me. You know that some people have confusion about this line, that is this line. So I want to tell you, because enthalpy lines are what? Uniformly spaced. WBT lines are non-uniformly spaced, so definitely they will not going to coincide, right? But I can say that constant wave temperature lines are downhill, straight line to the right. Right, it's correct. That is this one, and this one is correct, my dear. So option number 1 will be correct. This is nothing but a psychrometry chart, if you remember. Very good. 2 and 4. No. That's why I say Vamshi Krishna. It's not like that. Krishna, listen to me. Because you know that WBT lines are non-uniformly spaced, whereas enthalpy lines are uniformly spaced. So definitely they will not coincide. So 2 and 3 will be the most correct option, right? Okay. I hope you got it. Here I go for next. Atmospheric air at flow rate of 3 kg per second. Mass is given. Okay. mass flow rate on dry basis. Okay, enters cooling and dehumidifying coil. This is very important. Dehumidifying, right? With an enthalpy of inlet and enthalpy at inlet 85 kilojoule per kg of dry air and humidity ratio 19 gram per kg of dry air. That is omega. It is what, bacha? Omega. The air leaves the coil with an enthalpy of 43 kilojoule per kg. Dry air and humidity ratio is 8 gram per kg of dry air. If the condensate water leaves the coil with enthalpy of 67 kilojoule per kg. Okay. The required cooling capacity of the coil in kilowatt is. The required cooling capacity of the coil in kilowatt is. We have to find out cooling capacity. Guys, yes or no? Okay, okay, Bacha Badi. So how we can find out? Yes, tell me. Omega 1, you know that, right? Humidity ratio at omega 1 and omega 2 both are given, right? Yes or no? Of course it is given, right now? Yes or no, Bacha Party? Yes, very good. So now how we can find out? कैसे find out करेंगे बच्चा पार्टी? Come on, be fast. Be fast, बच्चा पार्टी. Okay, so listen to me. Okay, so here listen to me. You know that omega 1 is given. Omega 1, that is 19 gram per kg of dry air. Okay, I'm just writing. Okay, and omega 2 is what, my dear? Omega 2 8 gram per kg of dry air. Omega 1 is equal to what, bacha? mv1 upon ma. So my dear, from here I'll get mv1 and that will be what, my dear? Ma into omega 1. So it will become how much? Ma is given right now. Kitna diya ma? No, sorry, 3. It is 3 into omega 1. 3 into omega 1, right? Omega 1 is 19. So what it should be, bacha? Kitna aa jayega? 57. 57 आ जाएगा. 57 into 10 raised to power minus 3. यहाँ पे 10 raised to power minus 3 करना पड़ेगा because it is in gram, right? Okay, I hope you got it. यहाँ पे 10 raised to power minus 3 कर सकते थे आप, but I have written. Similarly, my dear, I can find out mv2 same fashion. That is 3 into, it is what, my dear? 8. Right now, बच्चा party, Krishna, do you follow? Okay, dear. If you follow, then it's fine. See. 3 into 8 into 10 raised to power minus 3, that is what? 24 into 10 raised to power minus 3. Now you have mass of vapors at inlet and outlet, right? So now the required cooling capacity of the coil that you have to calculate, right? But you know that it is a dehumidifying coil. That means if you are cooling the air below the dew point temperature, definitely there is a removal of moisture, right? So my dear, see. Mass of water will be what? Or you can say mass of condensate water, you can say. So that will be what, my dear? mv1 minus mv2. So mv1 is what, my dear? 57 minus 24 into 10 raised to power minus 3. So it will be what, bacha? It is 33. Right? It is what, my dear? 33. Very good. It is 33 na? 33 aa jayega. Once you get this 33, my dear, now you can calculate the cooling capacity. So cooling capacity, how you can calculate? See, my dear. See, I'll tell you. Now you have to calculate cooling capacity. So see, I'll to tell you. First of all, the air, this is supposed to be, this is cooling coil, right? Air is coming, air is leaving, some water has been condensed, right? So my dear, what you'll do? See, I'll do, that is H1 minus H2 multiplied by mass of air, right? Minus what, bacha? That is enthalpy of water, right? Enthalpy of water multiplied by mass of water, right? So H1 is given. H1 is what, bacha? H1 is 85, I think. 85 minus 43, right? And water is given, that is 67. 85 minus 43 plus mass 3 kg, right? Minus H2O, that is what, my dear? 67 multiplied by 0.033, right? So from here you'll get, and it will come around, bacha party. Kitna aa raha hai? Krishna, it's how much? It is nothing but 123.8. It is 123.8 kilowatt. It's very simple. Yes, Krishna, if you have any doubt, then you can tell me. If you have any doubts, Krishna, then please tell me. If you have any doubts, yes. Okay, those who have doubts in this session, please tell me. If you have any kind of a questions, Krishna. Okay, so I hope you got it. It's a very easy question. Simply, you have to just take a difference of the enthalpies multiplied by the mass of the air minus what, my dear? Enthalpy of the air. But here the tricky part is quite finding out the mass of water, or you can say mass of condensate water. It is quite turning point of this numerical. Okay, I hope you got it, bacha party. So here I go for next. Air at atmospheric pressure, okay, at a dry bulb temperature of 40 degrees centigrade and wet bulb temperature of 20 degrees centigrade, okay, is humidified in an air washer operating with continuous water recirculation. Okay, the wet bulb depression, that is the difference between the dry and wet bulb temperature at the exit, is 25% of that of inlet. At the exit is what, my dear? 25% of that of inlet. Okay, at the inlet. Okay, the dry bulb temperature at the exit of the air washer is closest to, see, my dear, again I repeat, they are asking the dry bulb temperature at the exit of air washer. So you have to calculate, right? And each and everything is given. See, again, dry bulb temperature is given, wet bulb temperature is given, and process is what? Humidification, air washer, continuous water circulation, the wet bulb depression, that is difference at the exit is 25% that of inlet. जितना inlet में होगा उतना ही कहां पे होगा? Exit पे. Okay, so they have given. So now guys, we have to calculate. Okay, we have to calculate. So how we can start the numerical? Yes, bacha party, please tell me. Wet bulb depression, right now. I hope you got it. See, my dear, it's very simple. You know that wet bulb depression is nothing but what? Dry bulb temperature minus wet bulb temperature. So my dear, dry bulb temperature minus wet bulb temperature at exit, that is 2, is equal to what? 25% means what? 0.25 of what? Dry bulb temperature minus WBT at 1. So it is what, my dear? 0.25 dry bulb temperature, that is none other than what, बच्चा? कितना है यहाँ पे? It is 40. So you can took difference लेना है, तो there is no effect on it, right? So 40 minus 20. So my dear, it is what? 0.25 multiplied by, that is 4. 4 na? Yes, it's 4, I think. No, it's not 4. I think it's 5. So dBT minus WBT at 2 is what, my dear? 5. कितना आ गया वो? वो आ गया 5. Now my dear, now you know that wet bulb temperature is given, that is 20. ये कितना दिया हुआ है? Wet bulb temperature कितना दिया हुआ? 20. So definitely dry bulb temperature at exit will be what, my dear? 20 plus 5, and that will be 25 degrees Celsius. See how much this is very simple. This is very simple question, and it has been asked in the GATE examination. And the correct option will be number 3. I hope you got it. Yes, Krishna, I hope you got it, bacha. The guys, those who are watching, I want to tell you guys, you can see that it is very simple question, very simple, that you have simply try to understand the meaning, and then you have to apply that particular funda on that particular condition, right? So here I go for next. Moist air at a pressure of 100 kilopascal. pressure is given 100 kilopascal. Compressed to 500, that is P1 is this, P1, P2 is this, okay. Then cool to 35 degrees centigrade in an after cooler, okay. The air at the entry of after cooler is unsaturated. That means relative humidity is less than from 100 and becomes saturated at the exit of after cooler, that is relative humidity phi is equal to 100%. The saturation pressure of water at 35 degrees centigrade is this much, okay. The partial pressure of water vapor in the moist air entering the compressor is closest to, they are asking PV. Bacha party, we have to calculate PV. Now how we can proceed, how we can start the numerical, guys please tell me. Saturated means PV is equal to PVS, right? Yes or no? So my dear, PV will be what, my dear? PV will be what? 5.628. Yes or no, bacha party? Please calculate each and everything. Please calculate. Yes. Okay. So guys, now we'll proceed. Proceed karenge. So here we go. Here we go, my dear. Chale aage. Can we go ahead? So here. Okay. So here. Very good, Sam. Very good. Very good. Very good, Sam. See, my dear. Where is what they said? The just saturated at the exit. That means I can say PV by PVS is equal to 1. That is phi now. So I can say, my dear, PV is already given. That is, sorry, PVS is given. So I can say that PV is what, 5.628. Right? Right now. The partial pressure of water vapor in the moist air entering the compressor is closest to. My dear, I can say omega will be what, bacha? 0.622 PV upon P minus PV. Right? So it is what? 0.622 PV is what? 5.628 divided by, यहाँ पे कितना लेंगे बच्चा पार्टी? 100 kilopascal is given. 100 kilopascal is given. So my dear, from here you will get omega, and this omega will come. This omega कितना आएगा बच्चा ये? This omega will come around how much? It is how much? It is 7.0809. 7.0809 into 10 raised to power minus 3 kg of vapor per kg of dry air, right? ये आ जाएगी omega. Am I right now? But I want to tell you one thing. See, the air at the entry of after cooler is unsaturated and becomes just saturated at the exit cooler. The saturation pressure is given. Now we have to find out exit. Exit पे we have to find out this one. So omega will remain same. Omega तो same रहेगा ना? Yes. So my dear, see what I'll do now. If it is same, then again I'll write the paper, that is equation omega is equal to 0.622 PV upon P minus PV. Right? Anybody having doubts? No doubts. Very good. So guys, what it should be, we have already this value 0.809 into 10 raised to power minus 3, 0.622 PV divided by what, my dear? कितना है बच्चा? It is 100 minus PV. Right now, it is 100 minus PV. PV we have to find out. So my dear, from here you will get PV, and PV कितना आ रहा है बच्चा पार्टी? PV कितना आ रहा है? PV will be 1.125. PV is equal to 1.125. Okay, 1.125 kilopascal. So option will be, my dear, 1.12. That means this one, nearest option, number 2. Okay, everybody, you got it? Yes, Krishna, Sam. Guys, had you got it? Had you got it, this thing? Sam, Krishna, and anybody else, those who are watching? Yes, very good. It's very easy question. Now the another one. We have taken this one. Now we are going to another one. In an ideal vapor compression refrigeration cycle, specific enthalpy of refrigerant in the following state is given. Okay, no issue. So my dear, you know that. This is our TS diagram, right now. I'm just drawing the diagram for your understanding, okay? Otherwise, there is no need to draw it. In the examination, don't draw the diagram. Your preparation should be in such a level that there is no need to draw the diagram. That will save your time. And we have to save my time, my dear, for this kind of questions. If you're not able to handle this kind of question without any kind of detail analysis, my dear, then you have to think that where your preparation is. Kahan pe hai aapki preparation? Okay, so it should be 1, 2, 3, 4, right? Inlet of condenser, that is nothing but H2 is given 283 kilojoule per kg. Exit of condenser, that is S3, and you know that 3,4 is what isenthalpic process, so it should be S3 is equal to H4, that is what, my dear, 116 kilojoule per kg. Exit of evaporator, that is what, my dear, H1, that is 232. Okay, now COP, you know that refrigeration effect is nothing but H1 minus H4 divided by work required for compression of the refrigerant, and that is nothing but, my dear, in this diagram it is S2 minus H1, right? So bacha, it should be S2 minus H1. So my dear, now you put the value, that is 232 minus 116 left, right? S2, that is 283 minus 232. So from here you'll get COP, and my dear, your COP will be very good. COP will be, you can ask, COP will be, that is 2.27. कितना आ रहा है बच्चा? 2.27 आ रहा है ना? Very good. It is 2.27. And this will be your answer. Okay, I hope you got it. 2.27. Very good, Krishna. That's very good thing, my dear. You have calculated. Very good. Now I'll go for next. Okay. Here is another question. Yes, everything is clear now. Very good. Moist air sample has dry bulb temperature 30 degrees centigrade. Dry bulb temperature is given. Okay. Specific humidity, that is 11.5 gram. G means what, my dear? Gram. Water vapor. Okay. Per kg of a dry air. Okay. That means gram per kg of dry air. Assume molecular weight of air 28.93. If the saturation vapor pressure of the water at 30 degrees centigrade is 4.24, okay, the total pressure is 90 kilopascal, then the relative humidity of air sample is, my dear, relative humidity we have to find out. Okay, that means we have to find out, bacha, phi, right? What we have to find out? We have to find out phi. Okay, so my dear, how we can find out? So it is nothing but PV by PVS, right? Yes or no, bacha party? So we have to find out PV first. Okay, PV we can find out. Once we get the PV, we can get anything, right? Yes or no? So my dear, here I go. You know that phi is equal to PV by PVS. We know PVS, but we don't know PV. So my dear, omega, you know that it is what, my dear? 0.622 PV divided by what, my dear? P minus PV. Right? So it should be what, bacha? 0.622 PV. Total pressure is given, that is none other than, kitna hai bacha ye? It is not given. So we can took it, kitna le lenge bacha party? We can took it, kitna le lenge? 90 kilopascal given hai shayad. 90 kilopascal. Right? 90 kilopascal. Okay. We can took 90. Okay, so here. Okay, bacha party, 90 minus PV. Okay, and it is what? It is in, we have to put it the value in kg. So it should be 11.5 into 10 raised to power minus 3 kg of vapor to the per kg of a dry air. Okay, I hope you got it. Yes or no? Here they have made total pressure 90 kilopascal. Okay, so my dear, from here you'll get PV. So PV kitna aa raha hai bacha? हम लोग जो एंथैल्पी बढ़ाते हैं कंप्रेशन वर्क से, वो कैसे कन्वर्ट होता है? व्हाट एग्जैक्ट क्वेश्चन, किसमें कन्वर्ट करने की बात कर रहे हैं आप सैम? कैन यू टेल मी? फॉर इन विच? यस, सो इट इज व्हाट माय डियर? 1.634. कितना है? 1.634. ओके, आई विल गो फॉर नेक्स्ट. इट इज 1.634 kilopascal. कितना बचा? kilopascal. Okay, now you know that PVS which is given, that is 4.24. so my dear I'll get 5 is equal to PV upon PVS. so my dear ये कितना आ जाएगा मेरा? it will be, हाँ, yes, so it should be what my dear? कितना आ रहा है ये? it will be around 0.3853. 0.3853 आएगा ये, that is 38.53%. okay, so guys, this is the required answer. This will be your 5. It's very simple. Okay Sam, let me take. Okay, H1 to H2. okay, see, I don't know Sam whether you are asking that how this H1, because you know once you do the compression, so definitely the pressure will be high, and my dear, but your pressure will be high as well as it is nothing but the temperature will also high, right? And we are taking air as an ideal gas, right? so if you are compressing air, so definitely how much air you have compressed, that will depend, because अगर pressure बढ़ेगा, if pressure increase, temperature also increase, right? so if pressure increase, temperature also increase, my dear, so definitely the heat content will increase, and we are taking this work in terms of what? Enthalpy, because enthalpy is nothing but what? For ideal gas, it is nothing but CPT1. It is a basic thermodynamics that we have already studied, CPT1, and we are putting this value, that is what? T1 minus T2, right? I hope you got it. Sam, I hope you got it, bacha. Okay, wait for your comment, mate. Okay, so here I go for next. See, a refrigerator operates between 120 kilopascal and 800 kilopascal in an ideal vapor compression cycle with R134. There is no chlorine in the R134. The refrigerant enters the compressor as saturated water, saturated vapor, and leaves the condenser as liquid. The mass flow rate of the refrigerant is given, that is MR, that is mass flow rate of refrigerant, is what, bacha? 0.2 kg per second. Okay, properties for R134A are as follows. The properties has been given, you know, enthalpy of vapor, enthalpy of liquid, entropy of vapor and liquid, both are given, as well as they have given the superheated condition as well, right? Okay, so we can see that, my dear, we can see that is they have given condition for the superheated, and they have given the condition for all the things. But what they are asking, see the next slide. So they are asking the rate at which the heat is extracted in kilojoule per second from refrigerated space. That is what, my dear, actually they are asking for refrigeration effect. The language is twisted in such a way that whatever the amount of heat you are removing from a particular space, that is nothing but you are producing that much amount of what? Refrigeration effect, or you can say cooling effect in that particular space. Supposed to be this is a room, okay, and if you are removing supposed to be 10 kilowatt of heat from here, if you are removing 10 kilowatt heat from here, so my dear, it is nothing but what? It is nothing but your refrigeration effect, because this is nothing but this is going to be a load on what? Refrigerator, right? And that the refrigerator had to remove the 10 kilowatt heat from this space. And so my dear, this 10 kilowatt will become what? Our refrigeration effect. I hope you got the concept of the refrigeration effect, my dear. Okay, okay, समझ आ रही है बात? So my dear, now we can calculate. So how we can calculate? हाँ जी बच्चा, it is nothing but H1 minus H4. क्या होगा बच्चा? It should be H1 minus H4. So you know that H1 is nothing but, क्या होगी H1? And what should be the H4? What should be the H4 and what should be the H1? Yes, बच्चा पार्टी. क्या होगा? Guys, be fast. Be fast. Yes, very good. Somebody is answering no. Guys, be fast. Okay, see. I'll tell you how to solve. Very good. See, I'll tell you how to solve. You know that this kind of diagram we have, right? Some people get confused कि सर ये solve कैसे होगा? I'll tell you. Just keep an eye on a screen, my dear. ध्यान से देखते रहिए, नहीं तो कुछ भी समझ में नहीं आएगा, सब धुआं धुआं दिखेगा, दिक्कत हो जाएगी. ओके okay, 1 2 3 4. You know that H3 is equal to H4, and my dear, you know that as H1 is equal to what? Hg at evaporator pressure, right? H3 is equal to H4 is nothing but what, my dear? At is what, my dear? It is Hf at condenser pressure, right? So my dear, if I see the chart, you know that refrigerator operating between 120 kilopascal and 800 kilopascal, right? So definitely the 800 kilopascal जो pressure होगा वो किसका होगा? हाँ जी बच्चा, 800 kilopascal will be the pressure of condenser, right? So my dear, see, देखिएगा, H ये कंडेंसर होगा, ये इवापोरेटर प्रेशर होगा. So definitely it is what, my dear? ये कितना है? 800, and it is what, my dear? It is 100. Let me check. It is 120. Sorry, it is 120. So my dear, what you are getting? S3 is equal to H4 is equal to HF, right now at condenser pressure. Condenser pressure means what, my dear? 800 kilopascal. Okay, so it should be 800 kilopascal. It is what, my dear? 95.5. okay, क्या हो गई ये 95.5 आ गई किलो जूल पर केजी. नाउ माय डियर, H1 is nothing but Hg at evaporator pressure. So Hg at evaporator pressure is nothing but 120 kilopascal. So I'll check 120 kilopascal में Hg, that is what, my dear? 237, right? So I have taken H1, that is what, my dear? 237. If I go for the next slide, my dear, what I'll write? I can write refrigeration effect is nothing but mass flow rate multiplied by H1 minus H4, right? Mass flow rate is given, that is none other than bacha party how much? Mass flow rate is given 0.2 kg. So 0.2 H1 is 237, right? Minus H4 95.5. So refrigeration effect will be what, bacha? कितना जाएगा ये? Refrigeration effect will be around what, my dear? It is 28.3. It is what, bacha? 28.3. So option number 28.3 will be the correct option. Okay, everybody got it? Very good. I hope you got it. Sam, Krishna, Sam and Krishna, I hope you got it, guys. Okay, so here I go for next. चलें आगे. So here I go. The power required for compressor in kilowatt. Now we have to find out power required for compressor in kilowatt. How we can calculate? हाँ जी बच्चा, for the same figure, the same question, power required to compressor, that is what, my dear? H2 minus H1. क्या होगा बच्चा? Mass flow rate multiplied by H2 minus H1, because you can see this is what, H2, and it is superheated, right? So what is the value superheated? Let me check. Enthalpy 276.45, right? So it is what, my dear? 0.2 276.45 H1. H1 is how much, bacha? H1 is how much? H1 HF, that is at 120, that is 237, right now? $237, right? So what will be the answer, my dear? The answer will be, क्या होगा बच्चा आंसर? The answer will be 7.9 kilowatts. It is what? H1 is how much? Let me check. H1 is how much, bacha party? We have H1, that is H2 minus H1. So H1 is no, H1 is different thing, na? H1 is 237, right? 237 है ना? I hope you got it. Yes, bacha party. H1 is 95. No, it's 237, right? Okay. So my dear, wait. Let me check once again. See H1, na? H1 means HG. HG at 120. That is 237, right now? Very good. So my dear, here we go. So it is how much, bacha? Kitna aa raha hai? Let me check once again. That is 237.45 minus 25.5 multiplied by 0.2. It's correct. 28.3 kilowatt. Right. So what about this one? 276.45 minus 237 multiplied by 0.2. 7.89 kilowatt. So it should be what, my dear? 7.9. Okay. I hope you got it, everybody. Here we go for next. Chalenge bacha aage. So here we go. Air room temperature. Room contains 35 kg of dry air and 0.5 kg of water vapor. The total pressure and temperature of the air in the room are 100 kilopascal and 25 degrees centigrade respectively. Given that the saturation pressure for water at 25 degrees centigrade is 3.17 kilopascal, relative humidity of air in the room is, the relative humidity of the air in the room is, my dear, see again, I'll repeat the question, listen to very carefully. Room contains 35 kg of a dry air, okay, and 0.5 kg of water vapor. Okay, the total pressure of the temperature of the air in the room is, the pressure and temperature of the air is given, that is 100 kilopascal and 25 degrees centigrade. Given that the saturation pressure of water at 25 degrees centigrade is PVS is given, that is 3.17. And now they are asking find out phi. What should be the phi? What should be the phi? Phi kya hogi, that we have to find out. So guys, how we can find out? Yes, bacha party, how we can find out? So simply just first you have to calculate. You have to calculate what, my dear? MV by MA kar lo. See, first you shall calculate omega is equal to what, bacha? 0.62 PV upon P minus PV. यहाँ से अगर PV मिल जाए, I'll get. But what is omega? So omega, you know that it is what, my dear? MV by MA. So MV is given. MV is what, my dear? It is 0.5, no? Divided by what? 35. So I think it's 1 by 70. Right now, 0.5 divided by 35. So I'll put the value, that is 1 by 70 is equal to 0.622 PV divided by P, total P. Total P, that is what? 100 minus PV. From here I'll get PV and PV will come around. PV kitna aega, bacha party? Bacha party, be fast. What is PV? PV is what, my dear? 2.253. Kitna aa raha hai? 2.253, right? So it is 2.253. Very simple numerical. So my dear, phi will be equal to PV upon PVS. So PV is what, my dear? 2.253 and PVS is given 3.17. So you'll get phi and phi will come around. Phi kitna hai, bacha? 0.71. Fourth one. Okay. I hope you got it. Yes. Guys, do you follow me? Do you follow? Please try to follow. Please try to get each and everything. See that how I approach the numerical. Thermal science is very easy part. And then I want to tell you, it carries around 20 to 25 marks in your examination. In your examination. I hope you got it. I hope you got it, Bacha Party. Okay. I hope you got it. Okay, my dear. So here I go for next. Chale aage. Here I go for next, Bacha Party. Now the next numerical. See. The pressure, dry bulb temperature and relative humidity, that is phi. Pressure, dry bulb temperature and relative humidity 1 bar 30 and 70%. Okay. If the saturated steam pressure is given at 30 is what, my dear? PVS, that is 4.25. The specific humidity of the room, air in kg per kg of dry air, we have to find out omega. And you know that omega is what, my dear? It is nothing but 0.622 PV upon PVS. You know that phi is given, that is 0.7. It is nothing but PV upon PVS. It is not this one. Okay, sorry, it is not PVS, it is P minus PV. I'm very sorry, jaldi mein likha gaya wo. So phi, you know that it is 0.7. That is nothing but, I already explained, this PVS is given, this one, right? So my dear, from here you'll get PV. PV क्या हो जाएगा बच्चा पार्टी? Very good afternoon, Sagar. You're most welcome in the session. What should be the PV? हाँ जी बच्चा, PV will be 2.975. It's very easy question. It is 2.975. PVS is given in the question, that is 4.25. Bacha, you'll get this one, right? If you got PV, my dear, you can put the value omega 0.622 PV. That is what, my dear? 2.975 divided by what total pressure is given. Let me check. It is not given. That means we are going to took total pressure kitna le lenge bacha. If it is not mentioned, my dear, remember one more thing that I want to tell you. If in the question they have not mentioned the total pressure, then you have to took it 100 minus PV. PV is how much? 2.975. So my dear, from here you'll get the answer, and your answer will be, bacha party, how much? Your answer will be, yes bacha, it is 0.019. It is what, my dear? It is 0.019 kg per kg of dry air. Question देख लो सब, आसान आ रहा है. Every question is quite easy, but if you don't know the funda, my dear, in the world nothing tough than this. इससे कठिन कुछ नहीं हो सकता फिर जीवन में, अगर कंसेप्ट नहीं पता है तो. See how much I have to write, only 2-3 lines. 2 to 3 lines I have to write, and I'll get 1 mark in the GATE examination. And 1 mark means what, my dear? You are ahead of 1,000 people. Okay. Very good, Sagar. That's very good, dear. We have already started, that is GATE series, right? So my dear, we'll go for next. Chale aage question pe. This is the another question. See, my dear. Moist air having dry bulb temperature 35, relative humidity 100%, that is dry bulb is equal to wet bulb is equal to dPT. Right now, it 100% means what, my dear? It is nothing but, it means dry bulb temperature is equal to wet bulb temperature is equal to dew point temperature. Humidity is entering psychometric device and leaving at 25 and 100% relative humidity. The name of the device is, वो device कौन सा होगा बच्चा? Please tell me. The temperature has been reduced. Please keep in mind. Yes, bacha. What it should be? Dehumidifier, sensible cooling, sensible heating. What it should be? Guys, which one? Very good, very good, very good, Sagar, Sam, everybody. Yes, very good, dear. I appreciate. See, क्या हो रहा होगा? I'll tell you. See, I'll show in the chart. You know that this is relative humidity line, so it is 100%, right now. यही होता है 100%. And my dear, see, that is what relative humidity remains 100%, right? Up this, right? But see, the dry bulb temperature is increased. What, my dear? It is what? Decreasing. Dry bulb temperature has been decreased from 35 to 25, right? And my dear, see, in this process, what happened? Relative humidity remains same ना, right? And उसका क्या हो रहा है? जो ओमेगा है वो चेंज हो रहा है. It has been dropping. So it is none other than what, my dear? It is dehumidification. That is removal of moisture. Okay, I hope you got it, Picha Party. I hope you got it. Very good. Nah, it's not sensible cooling. If you are doing sensible cooling, so my dear, it should be what? Your omega will remain constant and your dry bulb temperature is going to decrease in that case. Sam, I hope you got it, bacha. Sam, I have to tell you that if you are doing sensible cooling, so my dear, I want to tell you, here it is dry bulb temperature, right? It is increasing in this direction. So your cooling will be in this process. That is 1 to 2 is nothing but sensible cooling. And my dear, your omega will remain same. Omega will remain same. It will not change. But here the omega is going to change, and that is none other than what, my dear? Humidifier. Sorry, dehumidifier. Okay, no issue. Here I go for next. Next question. A reverse Carnot cycle refrigerator maintains at a temperature of -5 degrees centigrade. Okay. The ambient air temperature is 35 degrees centigrade. The heat gained by the refrigerator at continuous rate is 2.5 kilojoule per second. Okay. The power in watt required to pump the heat out continuously. We have to find out power. Carnot refrigerator is operating -5 ambient temperature and 35. 35 plus 273. What it should be, bacha? 35 plus 273. It should be what? 308. It is what, my dear? 7 3 10 0. Yes, it's 308 हो गया. ये कितना हो जाएगा? 268 minus 5 plus 273. It is what, my dear? 268 Kelvin, right? So my dear, see, COP of heat pump is nothing but what? TH. TH is how much? 308. TH minus T naught, that is 40. 40 का ही तो difference है. What you are getting? What you are getting, बच्चा party? Very good. What you are getting? कितना आ रहा है? जितना भी आ रहा हो यहां से कैलकुलेट कर सकते हैं आप. Very good. It's 7.5. Very good. It is 7.5. And you know that COP is also equal to what, my dear? Heating effect. QH divided by W. Right? And here they have said the heat gain by refrigerator at continuous rate of what, my dear? 2.5. Reverse Carnot refrigerator cycle बोला है. हमने heat pump निकाल दिया. Sorry. The power required. Oh, sorry. I have given for that is pump. It is not pump. It is what? अरे रेफ्रिजरेटर निकालना है बच्चा. रेफ्रिजरेटर. So COP is nothing but 268 divided by what, my dear? Divided by 308 minus 268. That is what? ये आता, ये किसके बराबर होता है? कंटिन्यूस. दैट इज रेफ्रिजरेशन इफेक्ट डिवाइडेड बाय W. यहां से आपका W आ जाता. इक्वेट कर दिया डायरेक्टली. मिस इंटरप्रेट कर गए थे हम क्वेश्चन को. आई एम वेरी सॉरी फॉर दैट. ओके. हाँ, 1 से माइनस भी कर लो. दैट इज सो आंसर विल बी व्हाट बच्चा? आंसर कितना आएगा? 373.13. कितना आ रहा है? 373 आ रहा है. $373.13, राइट? देखो 2.5 divided by 268. Okay, multiplied by. Okay, 373 watt होगा. watt. ये सब किलो जूल में है ना, ये सब किलो जूल में दिया हुआ है, ये इज इन किलो जूल पर सेकेंड ना, तो आपका 0.373 आएगा, बट वैट में क्या होगा 373, यहां से जो वैल्यू आएगी वो आएगी 0.373 किलो वैट, सो यू कैन कन्वर्ट इट इनटू वैट, राइट, वैट बोला है यहाँ पे, वेरी गुड। ऑयल इंडिया का क्या करवाते हैं बताओ। ओके ठीक है, आज कुछ प्लान करते हैं। ऑयल इंडिया का क्या चाह रहे हो आप मुझसे बताओ, ऑयल इंडिया का क्या चाह रहे हो आप? ऑयल इंडिया का क्या चाह रहे हो मैक्सिमम, प्लीज टेल मी। हियर वी हैव कम टू द अनदर क्वेश्चन, एक और क्वेश्चन, प्लीज सी द क्वेश्चन माय डियर। A sample of moist air at total pressure of 85 kilopascal has dry bulb temperature of 30, okay, saturation vapor pressure of water 4.24 kilopascal. If the air sample has a relative humidity of 65%, okay, the absolute, it's not absolute, it's absolute, huh? Absolute humidity in gram of water, that is we have to calculate omega, omega calculate करनी है हमें, how we can लास्ट ईयर इंपॉर्टेंट क्वेश्चंस, ओके, इंपॉर्टेंट क्वेश्चंस का एक कुछ कर सकते हैं, बट लास्ट ईयर आई हैव टू चेक इट आउट, ओके, लास्ट ईयर आई हैव टू चेक इट आउट, आई होप यू गॉट इट, वेरी गुड। सो 5 इज गिवन, 5 दिया हुआ है आपको, राइट ना, 5 इज गिवन ना, अरे हाँ या ना बच्चा पार्टी, 5 इज गिवन, सी phi is given, ये कैलकुलेट करना है, phi is what my dear, PV upon PVS, right, phi given 0.65%, that is 0.65 multiplied by PVS, PVS is how much, saturation pressure of 4.24 is equal to PV, so PV यहाँ से आ जाएगा मेरा 2.75 kilopascal, right, if I got this one my dear, I can put the value, that is 0.622 into, see these are the question from gate examination, these are very simple questions my dear, and total pressure कितना दिया हुआ है 85, so you'll get, they have asked absolute humidity in gram, हाँ please remember gram में बोला है, so what you are getting, जो भी आपको मिलेगा, we'll try कि करवा दें, कुछ ना कुछ करवा दें, don't worry, you are going to get in kg, right, आपको मिलेगा 0.0208 kg पर kg ऑफ ड्राई एयर, राइट, ये कितना हो जाएगा 20.8 ग्राम per kg of water vapor, right, so 20.8 will be the required answer, 20.8 will be the required answer, okay, we'll try max zone की करवा दें, कुछ ना कुछ करवा दें, don't worry, कुछ भौकाल करवा देंगे, don't worry, कुछ भौकाल सीरीज वगैरह लाके करवा देंगे, देखते हैं, लेट्स मी डू द एनालिसिस, राइट, एनालिसिस करूंगा, देन आई विल रियलाइज कि हाँ इसमें है कुछ करने लायक, आई विल डू, डोंट वरी, अदरवाइज मैंने बहुत सारे क्वेश्चन आपको करवा ही रखे हैं, यू कैन जस्ट ऑल्सो गो थ्रू इट ऑल्सो, उससे भी जा सकते हैं आप। अनदर क्वेश्चन, सी माय डियर, heat pump with refrigerant R22 is used for space heating between temperature -20, okay, and 25. Heat pump is there, right? The heat required is 200 megajoule per hour. Assume specific heat of vapor at the time of discharge as 0.98 kilojoule per kg Kelvin. Other relevant properties are given below. The enthalpy of the refrigerant at isentropic compressor discharge is what? Other relevant properties are given below. The enthalpy of the refrigerant at isentropic compressor discharge is what, my dear? Enthalpy of the refrigerant at isentropic compressor discharge. That means, my dear, S2 we have to calculate. Right now? Yes or no, bacha party? Of course, I hope you got it. Very good. That max zone we can't say, but we can expect that within month या 40 days में आ जाना चाहिए रिजल्ट, ऐसी आशा हम लोग कर सकते हैं उनसे, इसमें कुछ वो नहीं होगा, गलत नहीं होगा, ओके, आई होप यू गॉट इट बच्चा। सो माय डियर, फर्स्ट वी आर गोइंग टू ड्रॉ द डायग्राम, पहले तो डायग्राम ड्रॉ करेंगे इसका बढ़िया से, ठीक है, सी and this should be TS diagram. क्या होगा बच्चा, ये TS diagram होगा. Okay. Right. One, two, three, four. Right now. Okay. That is anti-clockwise cycle. Right, bacha? Now they are asking about S2. What should be the S2? Right. So my dear, see. You know that S1 is equal to S2 as it as isentropic. Right, bacha party. Right now. Of course, it is H1 is equal to S2. ये तो पक्का पता है S1 is equal to S2 हो जाएगा. And that is nothing but what, my dear? कितना हो जाएगा? Yes. It is how much? 1.7841. 1.7841, right? S1 is equal to S2, right? So now this is evaporator pressure. Let me check कि दिया है कि नहीं दिया properties. -20 पे S1, that means SF 0.9139 दिया है भाई, right? But एक बात देखें आप यहाँ पे, you can see here, my dear. I can also write this S1 is equal to S2. That is what, my dear? 1.7841. Right? 0.1. That is minus SG kahan hai? This one. Right? So, my dear, I can say S1 is equal to S2. That is 1.7841 kilojoule per kg Kelvin. Right? Right, bacha party? And this is supposed to be, this is a 3 point. Not this is supposed to be 5 point or a point, right? So my dear, I can say that what S2 is equal to what? SA plus CPV. CPV लेना पड़ेगा, right? Because there is a vapor. Vapor की वजह से we have to took the CPV. Don't do the mistake कि वहां पे आप वो ले लो, right? And it should be CPLN T2 by TA, right? CPLN T2 by TA. Right, bacha party? Now what is SA? SA is nothing but SG at what? Condenser pressure. See, my condenser pressure, sorry, condenser temperature 25. SG. So it should be what? 1.7183. Right now, SA क्या हो गया आपका? 1.7183 kilojoule per kg Kelvin. Right? I hope you got it. बच्चा पार्टी समझ आ रही है चीजें? Very good. Now I can calculate. यहां से मुझे क्या मिल? I'll get T2, right? I'll get T2 ना. See, my. अब मैं क्या करूंगा? S1, S2, I know that it is what? 1.7841. SA, I know that 1.7183 plus CP of vapor. CP of vapor, it is given 0.98 kilojoule per kg Kelvin. कितना दिया है बच्चा? 0.98. So I will took the value 0.98, right? क्या ले लूंगा मैं? 0.98 values ले लूंगा. L and T2 we have to determine, and TA we know that. TA हमें पता है, and TA is how much बच्चा? TA is how much? That is nothing but condenser pressure. So it should be what? कितना है बच्चा? 298 Kelvin में. It is 298 Kelvin, right? So my dear, from here you'll get T2, and आपका T2 जो आएगा, that T2's value will be what, my dear? It is nothing but कितना आ रहा है T2? 318.65. 318.65 Kelvin. So my dear, now you got T2 as well, right? So अब आपके पास में T2 है, right? And you have properties table as well, right? So what you can do, T2 मिलने के बाद, what I can write? S2 we have to determine, right? So what I can write? See, my dear, Now I have to determine S2. So I can write S2 is equal to HA plus CPV, and that should be what, my dear? T2 minus TA. So HA is what? HA is nothing but HG. HA is nothing but HG, and that should be what? This much. That is 413.02, right? So it is 413.02 plus 0.98. T2 is 318.65. TA, that is nothing but 298. Right, my dear? Kitna aa answer? Now tell me the answer for it. And the answer is nothing but what, bacha? Kitna aaya? It is 433.28. It is 433.28 kilojoule per kg. And what they asked, क्या पूछा था क्वेश्चन में? They have asked the enthalpy at the of the refrigerant at the exit of compressor or isentropic compressor discharge, that is the exit of compressor, that is H2 पूछा था, and we have find out H2, right? So this will be your required answer, my dear. This will be the required answer. Okay, so guys, this is all about from my side. Today we have finished the set number 1 for RAC. Tomorrow we are going to continue RAC, and after that, my dear, we'll begin IC engine. Okay, IC engine or power plant. So guys, yes, anybody have any doubts, please let me know and be fast. If you have any kind of a doubt, you can ask me. Yes, bacha party. If you have any kind of a doubt, you can ask me. Yes. Okay. So guys, this is from my side. Okay. And if you have any kind of a query, you can just mention your queries in the comment section. I will take your queries once the session has been over. अगर आप recorded session भी देख रहे हैं, so please put your queries in the comment section. I will take your queries and I will answer in comment. Okay. So guys, thank you so much for your patience and for listening very carefully. We'll see you in the next session. Okay. So take care. Bye bye. Shabba khair. One more thing that I want to add, please revise your short notes. Formula revise करें and then solve this mock test and test series whatever you have. Okay, टेस्ट बुक का जरूर अटेम्प्ट करिएगा. Okay, मॉक टेस्ट लगाइए. Don't waste your time on a topic wise. Go for the mock test because it's a time to appear for mock test. Mock test appear करने का टाइम आ चुका है. Attempt करिए उसको. So guys, take care. Bye bye. Shabba khair. We'll see you in the next session. And one more thing that I want to say, please stay at home, stay safe, stay online with the testbook.com.